Hi students, today our topic is electric potential energy. Otherwise they will say electrostatic potential energy. So already you came to know this potential energy word in first PU. So what is potential energy means we came to know energy possessed by object due to its position, first PU. Isn't it? Energy possessed by object by its own position. That is nothing but potential energy. Now either potential energy or kinetic energy or any energy in first PU, that one we got from work done. That work done only will be storing as energy. This is also now almost work done. Electrostatic or electric potential energy. Symbol is U. This is also work done. Okay. Potential energy also we got by using work done equation. Kinetic energy also we got by using work done equation. Strain energy. Okay. Strain energy in first PU we discussed all those by using work done equation only. Okay. This is also work done now. So what is that work done? What is that work done means? The amount of work done to assemble or configure some amount of charges at one place. Let us say I am taking three charges. Q1, Q2, Q3. I am bringing three charges Q1, Q2, Q3. I arrange like this. To arrange like this, I need to do some amount of work done. That work done will be storing as electrostatic potential energy or electric potential energy. Now what is the definition means? The amount of work done to assemble or configure. Configure means this is nothing but configuration. To assemble some amount of charges or system of charges at some place or at one place is called electrostatic potential energy. The amount of work done to assemble system of charges at one place is called electric potential energy or electrostatic potential energy. It is denoted by U. Now we are discussing what is electrostatic potential energy for two charges. Electrostatic potential energy for two charges. Now I am going to arrange two charges at one place. To arrange those two charges, how much work done I am doing? That work done only will be storing as potential energy. Let us assume two charges Q1 and Q2. Now I am bringing Q1 from infinite distance to one place here. That is nothing but I brought Q1 charge from infinite distance to this place. So to bring from infinite distance to this place, we no need to do any work done because here no electric field will be there. We no need to do any external work done against the direction of the electric field. This is point A. Now I am bringing another positive charge, that is nothing but Q up to here. So to bring another positive charge Q2 from infinite distance to this point, I should do some amount of work done because already here Q1 is there. What is the direction of the electric field? Q1 means like this it will be there. Isn't it? It will be there. Now against to the direction of the electric field I am doing some amount of work done. Now how much work I am doing to bring this charge up to here? What is the potential at point B due to Q1? What is the potential at point B due to Q1 means? First we should come to know this distance. This distance let us assume R. Okay. I am bringing charge Q2 up to distance R from infinite distance. Isn't it? Now what is the potential at point B due to Q1? What is the potential at point B due to Q1? Already we came to know that one. What is the potential equation? B is equal to Q1 by 4 pi epsilon naught R. V is equal to Q1 by 4 pi epsilon naught. You came to know general equation. V is equal to Q by 4 pi epsilon naught R. This is the potential at some distance R due to charge Q. This is potential at a distance R due to charge Q1. V is equal to Q1 by 4 pi epsilon naught R. Now how much work I did to bring Q2 from infinite distance to this point means potential at point B. V is equal to the amount of work done on which charge? Q2. Which charge I brought here? Q2. Therefore, the amount of work done to bring charge Q2 up to distance R. Then W is equal to Q2 into V. Q2 into what is V? Q1 by 4 pi epsilon naught R. This work done only will be storing as potential energy. This work done only we will write now U is equal to Q1 Q2 by Q1 Q2 by 4 pi epsilon naught R. This is the electrostatic potential energy for assembling two charges at some separation R. So what is electrostatic potential energy means? U is equal to, very simple, Q1 Q2 by 4 pi epsilon naught R. That is the equation. This derivation also important for you. Derive the equation for electrostatic potential energy for two charges. They will ask in the absence of electric field and in the presence of electric field. But this is in the absence of electric field. In the absence of electric field means here no electric field will be there. We brought Q1. Whenever no electric field is there to bring Q1, we didn't do any work. So whenever we brought Q1, then electric field is going to arise. Therefore, against to this electric field, we brought another charge Q2. But before initially there is no electric field. If electric field is there to bring Q1 also, you should do some amount of work done. That is separate case, we will see later. First, this is the electrostatic potential energy equation to assemble two number of charges at some separation R. Now we will see what is the electrostatic potential energy. What is the electrostatic potential energy for now three charges. Three charges. So this one we can remember directly equation only for problems purpose. It is important for you. They have never asked in PU. Only this equation only they asked for PU. What is electrostatic potential energy for three charges? Three charges means there is no electric field here. We brought Q1 from infinite distance. At point A, we brought Q1. We didn't do any work because no electric field. Now I brought another charge up to here. Q. Okay. So to bring charge, this is nothing but distance R12 at point B. Whenever I brought charge Q2 up to point B with the distance R12 from A, means how much work done I did means W1 is equal to Q1 Q2 by 4 pi epsilon naught R12 according to this. Now I brought another charge, that is nothing but Q3. Whenever I am bringing another charge and I am placing here, I am trying to place here at point C, which is at distance R23 from Q2, which is at distance R13 from Q1. Isn't it? Now, whenever I am bringing charge Q3 here, already two charges are there. Therefore, total work done now. First this one, Q1 Q3 by 4 pi epsilon naught R13 plus another work done Q3 Q2 by 4 pi epsilon naught R23. Now total work done. Total work done means U is equal to W1 plus W2. Then U is equal to Q1 Q2 by 4 pi epsilon naught R12 plus Q1 Q3 by 4 pi epsilon naught R13 plus Q2 Q3 by 4 pi epsilon naught R23. So this is nothing but electrostatic potential energy for assembling three number of charges at three different places. Three places we arrange. So to assemble two charges, this is the equation. To assemble three charges, this is the equation. Now I am going to give for you electrostatic potential energy for four charges. Four charges at four corners of a square or at different four corners, different distances also you can take. Just for simplification, for easily you can understand I am giving square. Now for four charges. So this is not required for you, for PU. Just I am giving whenever you are getting competitive problems. Now I am taking a square of each side. All sides will be same. Now I have to bring four charges. Q1, Q2, Q3, Q4. Whenever I am bringing first charge, I no need to do any work. Whenever I am bringing second charge, this is separation. Q1, Q2 by 4 pi epsilon naught here. Whenever I am bringing third charge, how many charges are there here? Two charges are there. Isn't it? Now, these three charges you have to do. Whenever I am bringing fourth charge, how many charges are there previously? 3 charges are there. Now you can fill the equation. Whenever we are bringing Q1, there is no other charge, isn't it? Q2, Q3, Q4 are not there. Whenever I am bringing Q1, therefore no work is done. Whenever I am bringing Q2, Q3, Q4 is not there. Only those two charges are there. Between these two charges you came to know. What is the formula? W1 is equal to Q1 Q2 by 4 pi epsilon naught A. Whenever I am bringing third charge means this distance you should find. What is this distance? Root 2A. Correct only? Now whenever I am bringing Q3, Q4 is not there. So these two and these two we have to take. Isn't it? What is these two? Work done. Q1, Q3 by 4 pi epsilon naught. What is the distance? Root 2A. What is these two? Q2, Q3 by 4 pi epsilon naught. This is the work done whenever I am bringing Q3. Now whenever I am bringing Q4, how many are there? 3 charges are there. Now between these two, work done. Q1, Q4 by 4 pi epsilon naught A. This is these two. Now these two. This distance also root 2A plus Q2, Q4 by 4 pi epsilon naught root 2A. Next, these two. Q3, Q4 by 4 pi epsilon naught A. Okay. These two and these two. So here one term, here two terms, here. Now total potential energy means you have to add all these. Now you can add and write one equation how much you are getting. That is nothing but final equation for assembling 4 charges. Like that, how many charges they are giving? You have to take those 2 charges. How many remaining charges are there? You have to take. This is not important for PU. Just I gave for competitive purpose how many charges they are going to give. Now here today we discussed in this session electrostatic potential energy like first PU. But here the amount of work done to assemble system of charges. System of charges means some people will take 2, some people will take 3, or but minimum how many means 2 charges. Minimum you should take 2 charges. To take one charge and to do, we don't need to do any work done. The amount of work done to assemble system of charges at one place is nothing but electrostatic potential energy. This equation you have to remember for 2 charges separated by some distance. This equation for 3 charges separated by some distances to assemble 3 charges. This is the work done to assemble 4 charges. You have to add and find. You have to find the final equation I am giving for you as some homework. Okay. Thank you.